All right, so welcome back after March break. We're just going to continue with our pre-AP unit. Just 1 second, yep. Okay, so before March break, we did the lesson on solving a linear system by using the method of substitution. And so I am going to actually do example 1 here using substitution, and then we're going to actually do it this new way. So I'm just going to write out example 1 here. 2x plus y equals 4. 4x minus y equals 2. And if we're going to use the method of substitution, the way substitution worked was first we would label our equations 1 and 2. And then we had to make a choice of in one of the equations to isolate a variable. And in the case of in 1 and 2, we have 2 options. Which equation do you want to choose, and what variable would you like to isolate here? Ariana?
I'm going to do 1 and y.
Isolate y in equation 1. You could also isolate y in equation 2, right? Either option. So if I choose equation 1 to isolate for y, if I leave y on the left side, what would happen to the 2x? Negative 2x, and then plus 4. So there's my rearranged version of equation 1. And none of you should be writing this in right now because I'm using the substitution method. Okay, so do not write. Okay, so substitute. Now, which equation are you going? Which one's going into which one? So is it 1 and 2 or 2 and 1? 1 is the one you rearrange that's going into 2. So we're substitute 1 into 2. So what happens is we get, here's equation 2. I'm going to copy the 4x. I'm going to copy the minus sign, but here's the catch. The whole point of this is y and this y are the same y. So I can replace y with what's equivalent to y, negative 2x plus 4.
Yep. You also just not put the minuses and just do bracket 2x, because to double.
No. You're going to mess up signs, trust me. Do it like this.
Okay.
So, because you have to remember that this entire expression, negative 2x plus 4, is getting replaced, the y is replaced with that. I would highly recommend you doing this instead of doing it in your head because you might forget to distribute the negative. So just literally say, I'm replacing y with this expression in brackets. Okay? Because why is this the key idea of substitution? You've taken an equation that had 2 variables, and now the equation only has 1 variable. And I can solve for 1 variable. Get x collected and isolated. So 4x minus negative 2x really should just be plus 2x. But this positive 4 is now minus 4, again, because we have to remember distributive property. And that could just as easily have a 3 next to it, and you might have to distribute negative 3. Okay, so you just got to be careful. And now if I isolate for x here, 4x plus 2x, 6x, maybe I'll do a little bit of work over here and say, okay, I'm going to add the x's over here. This 2, I'm going to add 4 to it. So I have 6x equals 6. X is 1. Okay, again, no one should be writing right now. You should just be watching. You shouldn't be on your phone either. Okay, so now, x equals 1. Now I'm half done. Okay, remind me. So why am I only half done? Because a point of intersection or a solution to a linear system always has an x and a y. So how do I find y? Here's an equation that I can use to find y. I'm going to substitute x equals 1 in equation 1. You can use original equation 1 or rearranged equation 1. They're both considered equation 1. Y equals negative 2 times 1 plus 4. Y equals negative 2 plus 4, which is 2. And then check 1, 2 in the equation you didn't use yet. Check in that one. Next year, you might have a teacher who wants you to check in both. You just do whatever their expectation is. Okay, I'm good with you just checking in the other one that you didn't just use. Remember, a proper check separates the left side and the right side. Okay, your left side of equation 2 was 4x minus y. Right side is 2. Our goal, hopefully, is when I plug in my numbers in for x and y, I should be able to confirm that I get the same thing on the left side and the right side. And so the solution is so you have found the point where those two lines, or those two equations would meet if you graphed them. And that's how substitution works. You should have completed all of the assigned work from substitution. If you didn't, you have a bit of catching up to do tonight. We are moving on to elimination. It's another way of solving a linear system. The way this method works, okay, is as follows. Step 1, determine if adding or subtracting like terms between the two equations will eliminate one of the variables. So what that means is I can eliminate a variable if I'm adding together two variable parts that are identical. Or I can either add or subtract to get rid of the like term. So what I mean by that, we'll see it with the examples. If neither of the variables can be eliminated by addition or subtraction, multiply one or both of the equations by a constant to create an equivalent linear system where one variable can be eliminated. So the goal is we want to almost treat our equations, we're going to line up the x terms, line up the y terms. We want to make either the x's look identical or exact opposite, or we want the y's to look identical or exact opposite. Because by making that happen, you're basically going to be allowed to eliminate one of the variables by adding or subtracting. Because if you see 2x and you take away 2x, let's say you see two equations, you see 2x and 2x. If I subtract 2x minus 2x, how many x's you got? 0x. But if you have negative 2x and 2x, well, you could still eliminate what's the operation you would have to do. Negative 2x and 2x. Add them, negative 2x plus 2x is also 0. So that's going to be the rules. Once you have eliminated a variable, you basically have the exact same scenario you have with substitution. You have an equation with only one variable. You proceed identically from that point on. So it's just the start that's different for elimination. Everything else is carbon copy the same. You find the one value, you substitute in to get your y or your x, the other one you didn't find, and then you check. Best thing to do is to just do it. So solve the following linear systems using the method of elimination. So these first two are nicely laid out for us that we can eliminate right away. Take a look at example 1. 2x plus y equals 4. 4x minus y equals 2. I'm still going to number them 1 and 2. Can you eliminate either the x's or the y's by adding or subtracting? You can eliminate, Owen?
You can eliminate the x's by subtraction.
Well, okay, right now if I look at the x's and I do 2x minus 4x, will all the x's be gone?
We did y's.
The y's are the key, because in that, do you guys agree the coefficients are the exact opposite, 1 and negative 1? What operation will I need to do to eliminate the y's? If they currently have opposite signs, I need to add. So I'm going to do something that you probably haven't seen in a long time. Do you guys remember adding like this?
Yeah.
Okay? So look at this, guys. I want you to you're going to set up, that's the best days of your math lives. Okay, it's been a while. Okay, so guys, I'm going to put a little line on the left side and the right side. It's bad form to just do a single line. The equal sign separates. So it should be, I'm adding the left side, I'm adding the right side. You can even put a little plus sign here to remind yourself what you're doing. I have to add the equation. So I know this is a little weird. The right side shouldn't be a big problem. I literally just did it. 4 plus 2 is 6. But on the right side, I'm just adding like terms. 2x plus 4x equals 6x Y plus negative y, gone. The y's were eliminated. Okay? You can even do that if you want. They match, so they're gone. Please, if you're going to do the little stroke outs, it's fine. Do not scribble it out that I can't see what's underneath. So just be single stroke, single stroke. Okay? Oh, can I solve 6x equals 6, guys? You found x equals 1.
Wow.
Okay, and just to refresh your memory, this is how we did it. This is how many steps we needed to do to get that same answer here.
Wow.
So this is typically why elimination students like better.
Yeah.
Okay, so I found x equals 1. Okay, I'm going to substitute. I'll do substitute x equals 1 in. So now here's the only kind of drawback is there's not really an obvious choice. You just pick one of the equations. Equation 1. So 2 times 1 plus y equals 4. 2 plus y equals 4. Y equals 4 minus 2. Y equals 2. Okay, and then check 1, 2 in equation 2, the one we didn't use. So if I check that point, again, left side, right side, 4x minus y is 2. There's the whole process of elimination. Okay? So let's try example 2. Now, take your quick look at the two equations. Do you see a variable part that's going to be, I can eliminate right away without doing any adjustment? Yep. The y's this time, there's 2y and 2y. This time they're the same sign. So what operation do I need to do to the equations to get rid of 2y and 2y? I need to subtract. So it's the exact same setup, except you're going to subtract this time. So be very careful. The sign matters when you subtract, right? You got to be very careful. X minus 3x. Negative 2x. You can't just decide I'm going to do the bottom minus the top, it'll be positive. No. You have to go in the same order, so I would just go, unit makes it negative, top minus bottom. Okay? So x minus 3x, negative 2x. 2y minus 2y, gone, eliminated, okay? And then 5 minus 7, negative 2. Okay, I've eliminated the y's, now I just need to isolate for x. X is, which is 1. Substitute x equals 1 into 1. 1 plus 2y equals 5. 2y equals 5 minus 1. 2y is 4. Y equals 4 over 2. Y equals. Okay, just so you know, the answer is not always going to be 1, 2.
Wait, why do you subtract instead of adding?
Where? Here?
At the very top.
Because these are the same signs. So if I added 2y plus 2y, I would get 4y.
Oh.
Now, again, check 1, 2 in 2. So this time I've got 3x plus 2y and 7. 3 times 1 plus 2 times 2. Oh, got a good feeling about this. Woohoo! So right now, I think, again, both methods will work. this will be the first step will be a little faster in these cases because you can eliminate a variable right away. You have an easier equation to solve pretty much right away. When we flip the page, we're going to notice a bit of an issue.
There isn't anything like
So, when you look at, I forgot, okay guys, don't get into good habits. Always label, because or else I'm not going to know what you mean by 1 and 2. I know it's kind of obvious, but still get in the habit of labeling 1 and 2. So, here's the issue here. So, I cannot eliminate right away here. But, I am allowed to change equations as long as I multiply every part of the equation by the same number. You've been doing that, remember, anytime you cleared a fraction in equations, you multiplied every part by the same number. So let's think logically here. Look at those two equations. What would be a logical, perhaps, I'll give you a bit of a hint. How could I change equation 2 so that I could eliminate? Yep.
multiply everything by 2.
Multiply everything by 2, and then you can eliminate the y's. Or you can multiply everything by 5 and eliminate the x's. Remember which one you want to do?
2.
Okay.
Easy.
So here's what you're going to do, guys. Times 2. Tell me that's what you're doing. I'm going to multiply it by 2. Now here, you can just draw like an arrow because I'm not changing equation 1, but you should rewrite it, and you're going to see why in a second. So I just rewrote the first equation. I'm not changing it. If you want, you go times 1, but that doesn't really do anything. For times 2, remember, every part of the equation gets multiplied by 2. So what happens to x plus y equals 15? 2x plus 2y equals 30. I consider that still equation 2. It's just been multiplied by 2, but it still means the same thing. You know, eliminate. So it all means, so you do this one little step to kind of get set up in the right mode. But now it's basically the exact same thing you just did. Again, make the choice. Am I adding or subtracting? Same sign. I'm going to give you a little bit of a memory device there. Do you guys see there's the same sign in front of the two y's? Same sign subtracts. Maybe like a snake. Same sign subtract. Opposite add. Go away. Okay, I don't know. Okay, vowels. Okay. Opposite add. Same sign subtract. Opposite add. Same sign subtract. So I see same sign. So I'm going to subtract. 5x minus 2x. 3x. 2y minus 2y. Eliminated. 48 minus 30. 48 minus 30, guys? 18. X is going to be 18, which is 6. Okay. So I'm going to substitute x equals 6 in, pick an equation. 1? 2 is easier. Okay, if you substitute in 2, now here's where I'd like, again, you can do either version of equation 2. I picked the original equation 2 in like 95% of the cases, just in case you made a mistake when you multiplied by 2. Because this is where you'll catch it. You'll get a number, and if you do your check, if it doesn't work out, you know you made your error when you multiplied by 2. Does that make sense? So I would always go back to the original. Tomorrow we'll talk about the one exception to the rule that I will let you do. So we're putting x equals 6 in equation 2, so that's going to be 6 plus y equals 15. Y equals 15.
Minus 6.
Y equals 9. And then check 6, 9 in equation 1. Do you get why we don't choose 2 again? Because you're basically just, if you made the mistake here, you're going to make it probably again here. Okay, use the equation you haven't touched since the very beginning. 6, 9 in equation 1. So I've got left side, right side, 5x plus 2y, and a 48 over here. So I'm going to put 5 times 6 plus 2 times 9.
Yay.
30 plus 18, 48. Left side equals right side. Therefore, the solution is 6, 9. Okay. Last one. You ready to go? 2x plus 9y equals -4. 5x minus 2y equals 39. Now, this time, how am I going to deal with this? Do you think I can do what I did last time? Do I only have to work with one, or do I have to do some adjustment to both? We don't want to go into, I think all of us agreed, we don't really want to go into, I'm going to multiply by 2.5. We don't really want to go into decimals, right? So let's think. If I want to get the same number, you have to make, basically here's your thought process. I have to either choose I want the numbers in front of x to be the same, or I want the numbers in front of y to be the same. And once you've made the choice of where you're going to focus, that's going to basically tell you what you need to do. Shall we go with the x's this time?
Yes.
So let's go with the x's this time. What would I have to do, like when I say 2x and 5x, what would be an appropriate choice of what we would like the number in front of those x's to be? That will match up with an easy multiplication of 2 and an easy multiplication of 5. I should make it 10. Are we all happy that 10 is the magic number? What do I need to do equation 1 to be for 2x to become 10x? And what do I need to do to the 5x to get to 10x? Okay. So, again, this is where people mess up. It's every part of the equation. Every single part gets multiplied by 5. 2x times 5, 10x. 9 plus 9y times 5. What's now the coefficient of y? 45. 45y. -4 times 5, -20. And now I'm multiplying by 2. 5x times 2, 10x. -2y times 2, -4y. 39 times 2. All right. And I have done the appropriate multiplication to make the 10x's be matched up. Do I add or subtract to eliminate 10x? Subtract, because in front of both, those 10x's are both positive, means they're both the same sign,
Subtract.
Thank you. So same sign, subtract, 10x minus 10x, 0x. 45y, here's where things get tricky, you have to be careful guys. 45y minus -4y, 49y. You have to be careful with those integers. Okay, back to the rules from like week 1 of the course. Okay, and -20 minus +78. So -20 minus 78, -98. Y equals -98 divided by 49.
-2.
-2. Okay, and this is where, if you want, you can kind of do your little, like, use some little, like, kind of lines to help separate your steps. So that was step 1. Okay, substitute y equals -2 in 1. Here it's like a tie of annoyingness. You just kind of have to deal with it. They're not really easy and a hard. They're kind of like a tie. So just deal with one of them. So -2 in equation 1. 2 times negative, whoop, wrong. 2 times x plus 9 times -2 equals -4.
Wait, is that 2x? What's the name?
2x, yeah, first equation, I just replaced the y with a -2. So I have 2x. What's the next thing I'm writing next to the 2x? using rules. Yep, good. Minus 18 equals negative 4. 2x equals negative 4 plus 18. 2x equals 14. X equals, which is check x, oh no, check the point. 7, negative 2 in equation 2. So we got 5x minus 2y is 39. So we've got 5 times 7 minus 2 times negative 2. 35 plus 4. 30. I'm hoping you guys are seeing the repetitiveness of how, like, basically once you get the like how it goes, it's very repetitive. Now, I'm going to ask you a question about this example. Would substitution be an appropriate choice for that system of equations? Think of substitution. The key to using substitution is in step 1, what do you want to do? You want to isolate a variable. Do you get that if you're going to isolate a variable in this example, you will be dealing with it substituting fractions. And we want to avoid that. That makes life complicated. So that's why elimination is one that we go to a bit more, because we can guarantee ourselves at least up to this point we're guaranteed no fractions. Now, I can't say that you'll never have a fraction as your x and y. That's up to the original equations. But we can avoid using fractions until we find that first value if we use elimination. Okay?
When do we ever quit?
By the end of this week, we'll talk about it a bit tomorrow. So where we're going with this, guys, is there's on the back of the sheet, so before March break, you got a sheet that had substitution on the front. It was your responsibility to complete that front page. Guess what? There's a back page. Elimination. And so now you're going to complete those questions. And again, it might seem like a lot, but the more you practice it, the more comfortable you get at it, it's going to help you throughout this entire rest of this unit, because all we're going to be doing the rest of this unit, I just want you to understand where we're going with this. Tomorrow we're going to look at more complicated equations. What if the equations you start with look like this?
Why would you want to do that to us?
What if you have two equations that start like this?
We would have to change the other.
Well, okay, so I just heard someone say, I don't know how to solve that. Could you make both of those equations look nicer? That's going to be what we're going to do. Do some pre-work, some algebra pre-work to make them look nice, and then worry about making your choice.
So would you open the top one, would you consider the fraction first?
Exactly. And we'll talk a bit about the second one. Could you think of something you could multiply the second one by that would make it not have decimals?
Yeah.
Oh, wait, 10.
Close.
Oh,
100. So you there is strategies to make not so nice looking equations look nice. Okay, guys? Please listen. That's going to be where we're at for the quiz. It's just going to be purely algebraic, the quiz. But then where we go from there is then we learn that we can model real life situations with systems of equations. So now that we know how to solve that, let's now solve problems that can be modeled with a linear system. And that's basically what we're doing for the rest of the year.
When will that be?
Thursday probably. Thursday or Friday, but I'm leaning towards Thursday. Alrighty guys, so there's 7 minutes left. So guess what? I want to see a couple of elimination questions happening. Let's go. You have 7 minutes of work time. Take out a piece of paper, get working. Wait, Miss, are you gonna give this back or?
Yeah, sure.
Yeah, I got it.